ENCOR Section 24 Summary Challenge. Infrastructure Security. Which option is not a typical use of ACLs? Route advertisement filtering. Well, oh no, actually we do have use for route advertisement filtering with ACLs. NAT control, VPN traffic identification, or PPP configuration. Okay, I'm not sure whether it all was covered in the course. Probably it was. I didn't read very thoroughly for this section. So definitely we can use ACLs for route advertisements filtering, like prefix filters and things like that. For net control, we do use ACLs, right? Because we identify, for example, the inside local addresses, which are eligible for translation with an ACL. VPN traffic identification, I think this is also used for VPN traffic identification, right? When we specify access lists and then this traffic matching the access list is tunneled through a VPN. And the only option which I'm kind of don't have knowledge about is PPP configuration. And from past experience, the PPP configuration is pretty straightforward. You just take a serial link and you specify encapsulation PPP, right? There is no any way to plug ACLs in at all. So I will stay with this last option here. Which address range is covered by the following IP address and wildcard mask combination? Okay, we have the wildcard 255 and 7 here, and we have 160 and 0 here. We'll need to do a little bit of calculation here. So the fourth octet doesn't matter because it is 255. We don't care what bits are there. So we need to really focus on the third octet over here, right? I will need to translate 160 into binary, right, to have this calculation. And 160 to binary will be 160 minus 128. Okay, we can subtract that, and like 128 here, and then we get 2 and 32 here, right? So subtract 64, we cannot do that. That will be 0. Subtract 31, we can do that, and minus 32 here, and then basically 0. So the rest will be 0 here, zeros, and 4 more zeros, overall 8 bits, okay? And then finally this 7 value, so this is the wildcard mask, means we don't care about these values, right? So we only care about this. And then the range will be from basically 0, 0, 0 in these 3 bits, right, to 1, 1, 1 in these 3 bits. And this is the border, and we actually do care what is here, and any value here will work. So, and that's very easy to calculate because this is 160 again, right? And 160 plus 111 will be 167. All right, so that should be from 10, 120, 160, 0, okay, to 10, 120, 167.255. So this is the correct option here. Okay, which 2 number ranges are used to identify extended ACLs? Oh, I knew there will be this question. So it is from 100 to 199, but also there is the extended range, and it is easy to identify it. In this specific question, I wouldn't remember like if I had to just write it out, but this is the correct option here, and this is the additional range for the standard ACLs, right? So these are standard. These are standard plus one of them is the extended. 100 is an extended ACL. These all are extended except for the last one. I'm not sure which range it belongs to. Yeah, and as I said, these are just additional range of standard ACLs. As we are asked about extended, these are two correct options. Which command would produce the following output? Okay, we have the output of an access list with statements. It is an extended access list and it is a named access list, right? So obviously this will be a show command, and very simply it will be the show access lists command, right? Yeah, I think there will be also one more line here in between the prompt and actually the statements, which will indicate either the number or the name of the access list. But anyway, it will be show access list. Show run section access list. It will also produce the similar output, but there will be, I think there will be no numbering of the statements, and or definitely there will be no count of matches for the statements. So this is the correct answer. Question 5. Refer to exhibit. This ACL is applied on traffic outbound from the router on the interface that directly connects to 10.0.70.5 server. Okay. A request for information from a secure web page is sent from host 10.0.55.23 and is destined to 10.0.7.5, or to that server, basically. Okay? Which line of the access list will cause the router to take action, forward or drop? Okay, let's see. We have the source and the destination. Okay, we have the access list, which is applied outbound to the interface that directly connects here. Okay, so I think I can draw it out very quickly, right? So here is the server, here is our router, and this is our connection. And here we have the ACL applied in the outbound direction, right? And this is the IP address of the server, and this is the IP address of whatever host is here. Okay. And it is a secure web page, which means the TCP port number is 443 for HTTPS. And is that it? Okay, it looks like this is the correct answer right away because, okay, let's see whether anything else will match prior to this statement over here, right? So permit TCP host 10.0.55.23, okay, to host 10.0.70.55 equals 1719 equals 1720. So these will not be matched, right? So this will just be passed because they specify the TCP port, TCP destination port, and in our case, the destination port is secure web page request, which is the HTTPS protocol, and then this statement will be matched, right? And as simple as that. And the traffic will be denied because of the action indicated here. So number 3 is the correct answer. In applying an ACL to a router interface, which traffic is designated as outbound? Okay, traffic that is coming from the source IP address into the router. No, this is not correct. Traffic that is leaving the router and going toward the destination host. That looks good. Leaving the router, going towards the destination host. Okay. Traffic that is going from the destination IP address into the router. Not correct. Traffic for which the router can find no routing table entry. This is also not correct. So, very simple question. Outbound means outside of the router. Refer to the exhibit. Again, the network administrator has the IP address of 10.0.70.23/25 to have access to the corporate server. So 23. Okay, let me. This one. oh no, not this one, but rather this one, 7023, to access the FTP server. Okay. 54.5, okay. The FTP server is also a web server that is accessible to all internal employees on networks within the 10 range IP addresses. No other traffic should be allowed to this server. Based on the ACL below, how would this ACL be applied? Okay, so we have the ACL already written out for us, okay? And it needs to be applied. First thing, we need to take a look at which type of ACL is this. And this is an extended ACL, right? And there is a rule for extended ACLs. Extended ACLs need to be applied further to the source, as close to the source as possible, right? So let's see what source we have here. This is our source, 70.23, okay? And this is the same source. And now we have 10.0.0, this network, right? So which includes this network, and this network too, right? And then deny IP any, okay, so this is not an indication. So here, I think the proper way to do that, because our source is not just one network, but it's a collection of networks, right? And we need, of course, if we only apply it here, for example, as close to this source as possible, this statement will not be doing its work, right? Because it has to apply to any packets that are traveling from any of these three networks. So kind of we need to summarize this source. And that makes it clear that we need to apply this ACL on router 1 on interface gigabit 0/0 into the outbound direction from this interface. Another option possibly could be applied here and here. So like on two interfaces into the inbound direction. Could be also good, but yeah, I mean, depending on the network design we have. The go-to option would be this one. So gigabit 0/0 outbound. Gigabit 0/0 outbound. This is the option. Okay. Which command is used to activate an IPv4 ACL named sales on an interface so that the router filters traffic prior to it accessing the routing table? IP access group sales in. Yeah, that's the command, right? The whole point of this question is filtering prior to accessing the routing table, okay, on entering into the router. And this is what the in keyword stands for. And this another one is IP access class. IP access class command is used to apply access list to virtual terminal lines, not router interfaces. Refer to the exhibit. Based on the named extended ACLs configured, the line matching port 443 refers to which protocol? HTTPS. Quite a simple question, unless there is some catch here. Based on the named extended ACL, the matching port 443, which protocol? Yeah, it's just HTTPS, as simple as that. Okay. Which three types of traffic is the router service plane responsible for processing? Okay, three types of traffic, the service plane. Okay, service plane. I think service plane is responsible for things like MPLS VPN, GRE, and QoS. I think that's what it is. Right. So not sure how to explain it, but like BGP, Telnet, and ICMP, I think these are the management plane. right? And service plane is sort of user traffic. It's almost the same as the data plane traffic and packets, but it may need some special care and higher touch from the router and some processing. Maybe some parts of this traffic are processed by the CPU. Okay. Which of these is not a feature of COP? So COP is the control plane policing. And let's see, permits or denies access to the data plane. And I think this is the correct answer, right? To me, it looks as a good answer to this question. So COP, what it does, it rate limits access to the control plane. Exactly. That's even what the lab was about. The police statement and bit rates, like data rates. Yeah, rate limits. Easily managed compared to infrastructure ACLs. Yes, so it is correct. Applies to a virtual interface tied to the control plane. Yes, from the global config mode, we type control plane, and then we get into this virtual interface configuration and apply service policy over there. Uses MQC for configuration. MQC. I think MQC is what has been referred previously, a few sections back, in the quality of service. And this is something like the CLI mode of configuration QoS that has this approach with class map definition, then policy map definition, and then application of the policy. And this also applies to COP. So I will stay with the pretty obvious first answer. It doesn't have anything to do with data plane. Refer to the exhibit. How will telnet packets from host 10.1111 be treated by the configured COP policy? Okay, telnet from 10.1111. First, let's see which or how this will match to the class map. So we have class map, which is just based on access group 100, which is this access list. Let's see. So access list 100 deny TCP host 10.111. Any equals telnet. Okay, so a packet from this host, which goes to port 23, telnet port, will match this first statement of the ACL. All right? The action here is deny, which means that these and further statements will not be even checked. This deny action will just not include this traffic into this class map. So this traffic will not be part of this class map, telnet class. Therefore, it will not match here into this policy map, telnet policy, and it will not be policed according to this statement. All right? Yeah, so some kind of default policy will work, which is, I guess, just open, and there is no any kind of default class specified here. So let's see if we have such option to respond. Telnet packets from host will be dropped at the inbound interface. No, they will not be dropped. Despite the deny statement here, deny action, we are not applying, because we are not applying this access list to the interface, it will not drop packets. It will just not include these packets into this class map. Okay, telnet packets from host will be policed to 8 kbps. They will not be policed. Telnet packets from this host will be permitted without policing, and I think this is the correct option. Telnet packets will be dropped by the COP policy. They will not be dropped by the policy. Okay, I think this is the correct answer. Refer to the exhibit which two statements are correct. Show policy map control plane. So show policy map control plane command, it provides the information about how the policy map is configured for control plane, as well as some live data. So for example, over here we see conformed 90 packets, exceeded 30 packets. And conformed packets were transmitted and exceeded packets were dropped. So things like that. And we have one class map, top C. Another class map is class default. Okay. Let's see statements. How many? Two. Okay, so we have two correct statements here. A total of 120 packets matched the top C class map. Yes, I think that's correct, right? 120 packets matched this class map. 90 of them were have conformed, and 30 have exceeded the rate. So this looks like a good answer. A total of 1,137 packets have been rate limited by the COP policy. No, so 1,137, this number over here, was actually not limited, not rate limited by the COP policy, because they have matched the class default, and yeah, there is no any policing associated with this class. The FDIN policy is applied to the data plane. FDIN, what's that is? Or it's actually not of the FOIN, service policy input. The FOIN policy is applied to the data plane. No, oh no, of course, this is the policy, right? So this is the service policy which is applied, but it is of course applied to the control plane. It is not applied to the data plane. Access list 150 is used to classify COP traffic. 150. Well, yeah, that looks like the correct answer. Top C is the class map, and it is tied to the access list 150. And we can see it in this statement. Access list 150 is used to classify COP traffic. Yes, yeah, so COP traffic is what is being policed here by this class map, and it is tied to this access list. 30 packets have conformed to the TCP/C policing rate. TCP/C. 30. No, 30 packets have actually exceeded. I think I misread the name of the class map before, so it's not top C, it's TCP/C. Okay, so these two options are good.